Hi everyone. So we had a great day of notes, 6.1 notes. You're going to want this paper maybe. What we're going to do right now is I'm going to help us get started on these practice problems, okay? So you need a book and I'm going to use graph paper if you have that, but lined paper, I did it on lined paper earlier and it was fine, but I'm actually going to make this video with lined paper. So we're going to go to the 6.1 exercises in the book, and we're going to do 1 through 8. But I'm only going to help you on ones that I think you need help on. So number 1, you see how it says a particle starts at x equals 0 and moves along the x-axis with velocity equal to 5. Well, we already did that in class where you go 1, 2, 3, 4, 5. You're going to draw a horizontal line, label your units. Oh, they didn't give us units. Where is a particle at 4? That's where you go 5 times 4, and that will be a rectangle, and you find that area. Okay? Because velocity times time is distance. Where is the particle? Okay. We're going to start with number 2, because number 2 is different than what we saw in class. So if a particle starts at x equals 0, moves along the x-axis with a velocity equal to 2t plus 1 for time greater than 0, where is a particle at t equals 4? Watch this trick. Remember, plug in 4 into here to see what's the biggest y value we're going to need. So what's 2 times 4 plus 1? 9. So when I make our number 2 graph, I hope you guys can hear me. We're going to go to, we need it to at least go to 9. So let's see, where am I at? 9, 8, 7, 6, 5, 4, 3, 2, 1. 0's here. Oh, there go the lights. Can you guys see it okay? I think so. Okay. So we're going from x equals 0. Where is the particle at time equals 4? I'm going to make this 1, 2, 3, 4, and this is my time axis, and then the velocity function, velocity was 2t plus 1. Okay, so let's graph this line. So when you plug in 0, we get 1. You plug in 1, we get 3, because it's up 2 over 1, correct? But whatever, why am I making this harder than it is? 1, 2, 3, 4, 5, 6, 7, 8, 9. Plug in 2, 2 times 2 plus 1 is 5. You get 7, and then when you plug in 4, you get 9. Okay. Now, we had rectangles, but this is not a rectangle. This is a trapezoid. And you can find the area if you want to chop this into a rectangle, this little small rectangle, and then add it to the area of a triangle. But you would look pretty silly because we know that, well, let's first start with the area will equal, this is velocity. The area is going to equal, I have my terms mixed up here. Let's go back. Let's erase. Area of a trapezoid. Ready? 1/2 the height times base 1 plus base 2. And the bases are parallel to each other. Okay? So what we're doing is we're going to take, what's this base? Or this length is 1. And we're going to add it to 9. So 1 plus 9 is 10. And what we're doing is we're saying we have a rectangle, like instead of going to 9, we're going to add that little 1 up here. And the area of this rectangle would be 4 times 10 if I were to make this a rectangle. But I don't want all of the rectangle, 4 times 10. I want half the rectangle. So it's half of 4 times 10. That's where the area of a trapezoid came from. Okay? If you were to look up on YouTube, area of a trapezoid, hopefully they would show you that. All right, 20. Do we have a, units. Sorry. Where is a particle at t equals 4? So at t equals 4, the particle is at 20 units. So if this is our rate, we find area under the rate between a certain time interval. And this is the area of a trapezoid formula. Trapezoid. Okay, I feel like I wrote down somewhere. Okay, you're going to do number 3 and 4. So number 4 is very similar to number 2. Okay, so 1, 2, 3, 4, and now I'm just going to go to a new page, okay? And show you 1, 2, 3, 4. So let's start with number 5. So 5 is similar to what we did in class, just easier, okay? So let's read number 5. A particle starts at x equals 0 and moves along the x-axis with a velocity of t squared plus 1 for time greater than or equal to 0. Where is a particle at t equals 4? So kind of similar, we're all seeing where it is at 4. Approximate the area under the curve using 4 rectangles of equal width and heights determined by the midpoint. So 4 rectangles, but we are using the midpoint height of the intervals as in example 2. I think it was example 1 in class. Okay, so t squared plus 1 is our velocity function. So velocity equals t squared plus 1, and we're going to time equals 4. So let's plug in 4. 4 squared is 16 plus 1 is 17. So I need a y-axis to go to 17. That's going to be the largest. So should we go by 2s? And let's make this, how about we make this 18, okay? So 2, 16, 14, 12, 10, 8, 6, 4, 2, 0. I'm going to double check that. I should have 9 marks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. And we're going from t 1, 2, 3, 4. And just wondering if I need a ruler. Pen. Are you doing this in pen or pencil? Should be using pencil. I'm using pen just so it shows up. 2, 4, 6, 8, 10. And that's my velocity or my rate. All right, I haven't made videos because I've been so sick and I feel like I have to cough. All right, let's graph this. So 0 squared plus 1, where's it hits the y-axis at 0, 1, and then plug in 1. So 1 squared plus 1 is 2. 2 squared is 4 plus 1 is 5. And 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. So it's our parabola just shifted up 1. And there we go. Okay, how many rectangles did it say to use? How many rectangles? Say just 4. Okay, why do we like 4 rectangles? If it says 4 rectangles, that's the same thing as saying 4 sub-intervals. So right now it's 1 interval from 0 to 4. We're going to cut it into sub-intervals. So 1, 2, 3, 4, and then it has to tell you. So it has to tell you this in the question, and then it has to tell you, are you doing a left, midpoint, or right? And in this question, it told us to do a midpoint height, right? Midpoint. Okay, so what we're going to do is in the middle, so not at 0 and not at 1, 0 would be left, 1 would be on the right, but we're going to go in the middle. So we're going to go at 1/2. This is going to be the height of our first rectangle here. And we practiced in class how to find that in the calculator. So then this will be the height. Now, midpoint, it gives you a little bit more accurate of an approximation, but it's harder to find that number, right? Because I don't know what 1.5 squared plus 1 is, okay? I don't know what 2.5 squared plus 1 is. So I could do it by hand. We could always do our long multiplication by hand, but we need to get out the calculator. Whereas if we were doing a left or a right, we already found those points, right? We already did those. Okay, now how do we organize this work? Do you remember how to do it? What are the headers going to look like? So we can use X or T. Should I use T this time? So let's use T. Let's hope I have enough room here. Okay, so T sub I, that's going to be the X values that we're plugging in to find the Y value. So the first time we're plugging in is 0.5, and then this one in the middle, 1.5, and we'll plug in 2.5, and then halfway between 3 and 4 is 3.5. Okay, then the next column will be F of those times. So Ti means T1, T2, T3, T4. So now we're going to find F of, well, shoot, should we make this real official? Isn't this V? Yeah, V of T. So that's going to be the height of this, okay? And I'm going to pause it, and I'm going to get out my calculator so that you guys can see it. All right, so here I am with a calculator, and I'm going to start tracing these Y values. This is very similar to what we did in class, so I'm not sure if this is the best use of our video time, because I might take the last minute to show you one more example. 5 and then 3.5, 13.25. I hope these are right. They look okay. All right. Okay, what do we need to do next? What's the point? The point is to find the area of these rectangles. What's the width of each? What's the width of? Well, you need the calculator to add it up, but okay, what's the width of each rectangle? So there's only 4 now, right? And what's here? This is only 1. 1, 1, 1. Change in T. How is T changing from 3 to 4? It's changing by 1. Okay, the last column is going to be the area of the 4 rectangles. So this is rectangle 1, 2, 3, 4, and these are our information. And so this is going to be the Y value times this, the width. So not this number. We don't need this number anymore. We've used it and we're done with it. We only used it to find the height of the rectangle. This is going to be this multiplication here. V times change in T. But what's change in T for all of them? 1. So you're going to write this all out and then add it up to find the sum. I'm going to pause and add it up. All right, I paused it and I added it up and we got an even number 25. That's odd, sorry. It's a whole number. So that was the sum of these 4 rectangles that I drew here. You can color them or shade them if you want. And we get 25 units because we're doing velocity times time is where was the particle. Okay, so the first goal would be to complete 1 through 8. I have a few seconds left. Number 6, so let me talk to you about 6, 7, and 8. Okay, number 6 is just a continuation of number 5. It says go to do a 5th rectangle. Okay, so you just use a 5th rectangle to find, not a 5th rectangle. Go one more, sorry, go to T equals 5. Okay, what if you made it bigger?